Hello, everyone. Thanks for joining today. My name is Daniel Sjoberg, and we're going to be talking about CDISC's emerging analysis results and data standard using the cards and the gtsummary packages. A couple projects that I really like, actually. So I hope I strike the balance between sharing with you the information that I want you to get, but also staying within the time limit. So let's get started. So we're going to begin today with the briefest introduction to CDISC's Analysis Results Standard, this ARS model, and where the analysis results data sets begins and fits underneath that umbrella of that fuller analysis results standard. And I want to also talk about how we can use ARDs to facilitate the reporting with and without utilizing that fuller ARS standard. And we're going to be talking, of course, about how to do that with the cards and the gtsummary package for reporting. So a bit about this analysis results standard. CDISC has given us standards for CDASH, STTM, ATOM, but after ATOM, we don't really have this standard to fit into the results space. And that's really where the ARS standard fills and comes in. So it really has two primary goals: to leverage analysis metadata to drive automation, which is great. We'd like to automate things. And also to support the storage and processing, traceability, and reproducibility of the results, which is something we also all like. Here's a brief outline of what that may look like. You're starting with a reporting event such as your DSUR, your CSR, and you have metadata saying what your analyses of interests are, and what those results are going to look like. And then you need to do some other processing to actually do the calculations and create your TLGs. And that's really where the cards and the gtsummary packages are going to jump in. So the cards package is going to be the engine for all of the analysis that we're going to be reporting in our TLGs, and gtsummary is going to be the engine that creates those summary tables. So an analysis results data set encodes statistical results in a machine-readable format. This can be very simple results like means and medians, but also be very complex results from complex models. But one thing that the ARD and the ARS model does not do is describe how your results are going to be used. So we're really focusing on the raw results here and not the layout of what they're going to look like when they go to an eventual figure under table. So one way you can think about it is you create your analysis results data, again, this data structure that has all of your results in it, your raw results, and you can create from there a large regulatory table, perhaps a more shorter, interesting table that someone might read the entire thing, for example, or even an illustrative figure. But one thing I really want to show here is that these results can be used again and again and again for various purposes. So outside of that fuller ARS model, ARDs are still very, very useful. I love the way you can use ARDs for QC. These highly structured data frames result in a much simpler QC process compared to trying to QC statistics that are already in summary tables or figures, for example. They have flexible data types. They can be stored as their like raw, their native R types, or XBT or Parquet, or even in YAML and JSON formats, which are language agnostic, of course. And ARDs integrate with the gtsummary package to create beautiful summary tables, and we'll touch on that as well at the end. So now that we've talked a little bit about what ARDs are, I think we should actually get our eyes on a couple of them to kind of show us what we're working with. So the cards package is part of the Pharmaverse. It contains a variety. In case you didn't see some of these graphics, we're going to go through them very, very quickly. gtsummary cards, they help us do the engine and for calculating statistics. My goodness, I apologize. Let's get through these. All right. So cards is part of the Pharmaverse. It contains many utilities for creating ARDs and can also be used within the AR workflow and also separately. And in the last 2 months since it was released, we've already getting 45,000 downloads per month on CRAN, which is pretty wild, which is, I was really pleased to see that. But here is what an ARD looks like. we're going to use our most basic function in the cards package called ARD continuous, and it has some default statistics that it's going to calculate for us. So here we're passing an ADSL dataset, and we are calculating the summary stats for the variable age, the column age. And you can see here that we have a very structured data frame here that's giving us by default the n, the mean, the standard deviation, median, what have you, some very common summary statistics. But of course, this is a very simple example, and we're going to show a more complex case here as well. So you can see here that we can also calculate all of our statistics by treatment arm, by just adding the by argument. This is all very simple. So if the standard defaults aren't exactly what you need, you can also calculate summary statistics for any function. That can be a user-defined function, any base function, or any function from a package in the R ecosystem. So in this example here, I am calculating the coefficient of variation, which is the standard deviation divided by the mean. And as you can see here that we get a data frame at the end here, our ARD, with our coefficients of variation by treatment group. There's also functionality for tabulating here. So that's an ARD categorical. So in this case, we are tabulating age group by arm. And you can see that we have a new column in here called variable level. So that's going to be our age group levels. And we're getting our counts, our denominator, and also the proportion within each one of those groups. There are a lot of other functions here that are very useful for various use cases. So dichotomous for dichotomous summaries, hierarchical for like AE, SOC type summaries, nested data. There's ARD complex, which is similar to ARD continuous in a lot of ways, but allows you to do multivariable instead of just simple univariable functions. And ARD missing for tabulating rates of missingness, and a number of others that are really helpful as well. Okay, let's move on to the cardx package. So I like to call this the extra cards package, where cards stands for CDISC Analysis Results Data Sets. The cardx package is going to be giving us extra utilities for other types of ARD creation that are from more complex statistical models. So the cardx package already exports ARD frameworks for a lot of statistical analyses, from the stats package, the CAR, effect size, survival, survey, LME4, a lot of packages. And this list is growing rather quickly at the moment, so which is really great to see. So here's a very, very simple t-test example. So I say complex statistical methods, and I'm going to show you the most simple example here. So you can see here that I'm starting with an ADSL data set. I'm filtering our treatment arm just to have two groups, because that's what the t-test expects. And I am here on line 3 doing a t-test by treatment arm for variable age. Once again, on this age variable is doing a lot of heavy lifting here. So you can see in these results that you see these estimates, which is going to be your mean difference. You have estimate 1, estimate 2, which are group means. You have your t-statistic. You have your p-values. You have your degrees of freedom, your confidence levels. You also have this method describes the Welch two-sample t-test. So those are all of the results when you run a t-test up on top. On the bottom, what you're seeing is the arguments that were used in the t.test function to create the results. So when you're reusing the results in 18 months, 24 months, 36 months, you know exactly how these results were calculated, which is super helpful in a lot of ways. You may also be looking at this data frame and noticing that most of these statistics are doubles, but then here at line 9, we have a character Welch two-sample t-test. That's because while most statistics are double, right, or just numeric, not everything needs to be like that. So our structure is actually a list column that allows for characters. It also allows for more complex results, such as like a variance covariance matrix, which isn't a scalar at all. So really anything can go in there. An entire model object could live in one of these cells as a result. So it's a very flexible framework. We also have functionality in cardx for summarizing nearly every type of regression model in the R ecosystem. And this work is building on what has been done in the Broom Helpers package. And it's been around for a number of years now, and it's super helpful, super robust, and can do a lot for us. And it includes packages like the MMRM, which are very common in our space in the pharmaceutical industry. So here's an example where I'm building a Cox proportional hazards regression model on top. And then I'm just doing a quick summary table, but I just wanted to illustrate here that all of the results you're seeing in this table are actually calculated in that ARD regression, that regression ARD function. So of course, you're seeing something you would expect, like the hazard ratio, the confidence limit for the slopes in the model and the p-values. But also note that this is contextually aware that this is a Cox regression, and it's showing us that this is the hazard ratio and not just some generic slope coefficient. It's also able to calculate on the top row here the n, so the number of observations that went into our model, and also the number of events. So the number of, in this case, the number of progressions that we observed in the follow-up period. And it can do the same for each level of the covariates. So for placebo, high dose, and low dose active treatment. But obviously, when you create a model like this, it has a reference group, which is in this case the placebo group, which does not appear in your raw output in R. So I can also identify those reference groups and allow you to use them in these kinds of tables, so there's no ambiguity about what your reference groups were. And one more thing I want to touch on here is that when you get the results from a regression model in R, and you have a categorical predictor or covariate, you see these things as terms. Each one of those levels -1 is a term in your model. But what this can do for you is it actually can identify that these terms belong together and they go to the arm variable. And it's even pulling in the label from the ADSL dataset for the variable arm and utilizing that too. So there's a lot of information and a lot of stuff that's happening in the background. Super, super useful when you're working with regression results. One of the things I really like about this package that is it handles things when they go wrong quite well. So in this example, I'm trying to calculate the kurtosis on a categorical variable or a character vector, which is not a thing that can happen. But when you get the results, you see that you have the data frame, the results, the ARD that looks exactly the same structure as what we had seen previously. But in the stat column, there's nothing because you can't actually calculate it. But there are new columns showing in the default print warning an error. And you can actually print those and see what actually happened and what actually went wrong when you were doing your calculating. So why I love this is that you can preemptively, super early on in your study, start creating all of these tables. And even when there's not enough data to calculate the statistics that you need, you're still going to get an ARD with the exact same structure that you were planning on. And you can just like build those table shells, or you can build those tables and NAs will go there, or X's for the table shells, for example. And now let's talk about ARDs and gtsummary. So gtsummary, very briefly, it began to address reproducibility issues while I was working in academia. And really the goal here was to build a package that could get summary tables for what we did most commonly. But we wanted the code to be very, very simple, but also very customizable. And the first release was in May 2019. So how is it going since 2019? I would say it's been really, really lovely and amazing to see its growth. So there's over 1 million installations from CRAN, 1,000 GitHub stars, 300 contributors, and 50 direct code contributors as well. And it's just been, like I said, really nice to see the growth of this package and see it picked up in many fields, from medical research to the pharmaceutical industry to economics, all sorts of places that I wasn't expecting. In 2021, the package won the ASA's Innovation and Programming Award. And this year, Augustin and I won the 2024 Posit Pharma Table contest by recreating an entire CSR with the package. Full disclosure, that was primarily Augustin's work. He did a fantastic job. And gtsummary now runs on ARDs. So while gtsummaries existed for a number of years, ARDs are somewhat new, and cards and cardx have only been around for a while. So this summer, I refactored gtsummary to run entirely on ARDs, which means every calculation done in a gtsummary table is done via cards and cardx, and you can extract those ARDs from the tabling object. So starting up here at the top, we can, on the left, we have a data frame. We can build a summary table, a TBL summary. We get a cute table. We can extract ARDs for those for reuse purposes. Or, of course, we have functionality to start with an ARD and also build your table from there. So both are very common workflows. So we're running a little short on time, so I might go a little bit fast through this, but here's an example of creating a very simple demographics table using gtsummary. And you can see that TBL summary is doing our primary work here, but it's very composable where you can add arguments for different kinds of displays. You can add new functions, pipe in add overall to get a new column of statistics, and add stat label to kind of change how those statistics are reported into the table. And you can then, from this object, you can use the gather ARD function to extract that ARD from the table. And here's an example of that exact same table with an ARD first framework, starting with a function in cards called ARD stack that will do those continuous and categorical variables in one call. And you can move on to the TBL summary, which has the same arguments essentially, and you have your table. So gtsummary is very composable, meaning very complex tables can be cobbled together quite easily, just like one piece at a time. And there are a lot of functions for doing all sorts of tables here. Before we go, though, I want to give a big shout out to the ARD team. Becca and I from GSK have been doing this collaboration for a number of months now, and we're delighted that Novartis has also recently joined our collaboration. So if your company is interested, please get in touch as well. Thank you for having me, everyone. Is it possible to remove the grid lines except the header in gtsummary? Absolutely. So the default printer for a gtsummary table is the GT package, and you can convert any gtsummary table to GT with an asgt function that's exported. And once you're working in the GT framework, you can use the hundreds of functions that are available there to style your table in really any way you want. GT is an incredibly powerful print engine. If GT is not what you need, you can also convert any GT summary to flex table, cable extra, Hux table, cable, or even directly to a table as well. Can you show how to unhide a column you might need that isn't printed by default? Yeah. So, for example, if you were reporting p-values or differences, we have hidden back there the test statistics, and there's a function called modify unhide column that you can just run to unhide any of the columns that you might want that are hidden by default. A docx format, yes. So GT does support docx exports as well as flex table too. So if you need docx, that is certainly a way you can do it. And 2 days ago, Becca, Jack, and I did a webinar, 3 hours, on cardx, GT summary, and also T format, which works fantastically with ARDs as well. And so there's a lot more details there.